So in our school textbook, so in our school textbooks, we all have learned about a formula, which is known as mirror formula and lens formula, that are quite different because of one sign. But if I write for the mirror, for example, 1 upon f is equal to 1 upon v plus 1 upon u. This is the mirror formula. And by this, we can, if we have any two, let's suppose f and v, we can find the u. And likewise, if we have two of any from this, if we have v and u, then we have f. So we can say that we have learned a relation between the object distance, then image distance, and the focal length of the mirror. Hmm. But when I was reading Isaac Newton's optics, I came across as this case 2 or CAL2. I don't know how to pronounce this, which said that which had this whole portion, which had- which is this. Now, what this says is something which is not. This is this in this book. This is the axiom 6, and it has this much written in it, which I'm not going to explain this over. But this I've understood this whole paragraph. So I got to know about one more relation that I can find between the V, U, and F, and that I'm going to explain here. Like what this says is, firstly, it is saying that let ACB be the reflecting surface of any sphere whose center is E. Now here don't have surface of any sphere whose center is E. So what I will do is name these spherical surface. Okay, it was written ACB. So I will write A and I think yes. So write it C and then B. So we know that C is the pole here. Okay. Now it's also said that center is Z. So let's suppose this is the center. So let's suppose that this is the center. So let's suppose this is the center of this uh, mirror, and we know that this is a concave mirror. Concave mirror, and then this is a concave mirror. Now, the next part says that bisect any radius thereof. Uh, this is written. Suppose, okay. Uh, I think this F-looking thing is S in this book. So, uh, bisect any radius thereof. Suppose pole EC in T. Okay. So we know that if E and C is the center, then EC will be radius. Now I have to bisect this. So I will something here I bisect it and name it P. Okay. Now next part says, and if in that radius on the same side the point, you take the points Q and small q, so that TQ, TE, and PQ be continual proportionals. Now, what is this continual proportionals? I searched it and I got to know about this is a proportional in which if there is given three numbers, okay, A, B, and C, then If I say that they are in continual proportions, then I mean is that A upon the B. Then if I say that A, B, and C are in continual proportional proportions, then it means that A upon B, this ratio will be equal to B upon C. Okay, this ratio is what this book is referring to. So what it is saying is that uh, and if in that radius on the same side, the point P, you take the points Q and Q, so that TQ, TE, and PQ be continual proportions. So firstly, let me write these. I mean PQ, TE, and TQ. So proportionals are given PQ, then PQ, TE, and TQ. TE and PQ. Now to write them in the continual proportions, I will choose this middle one as the common, I mean, denominator for this side, PQ upon TE is equal to TE upon T with small q. Now, if suppose I made this here some q, then it will be in this ratio. Okay. And now I have to see what this q and small q represents. So after taking this in continual proportionals, and the point Q be the focus of the incident rays. So if I suppose make capital Q here, and if I term it as incident ray, okay, which I will represent it as V, it means the object lies here, something. Then the and the point q shall be the incident rays, and the small q shall be the focus of the reflected ones. So this is the important. So the point q, which will be let's suppose this if suppose this is center and this is here, then the image will be formed here, right? Because in a concave mirror, if a ray or object is placed beyond the center, which I will name here P, okay, which I will name here P. So it will form an image which will be between the focus, which is E here, and which is okay, which is between the focus and the pole, which is here E as focus and C is as pole. So the image will lie at here. Now, what Newton is saying is that the P TQ upon TE will be equal to TE upon TQ. Now, this I have to prove. This is looking a bit confusing, but let me show you with an example. Like if I have question which has a that object is or object concave. If we take a concave mirror, okay, and then I make a line passing here, and if object distance of placed here is 25, which will be minus 25, and then V, which will be formed here because it is a concave mirror, and also it is I mean beyond this C F or V. And if I take its V or this I have to find it, and if I take F, now F is given 15, and it will be minus 15 because it a concave mirror. Then what will be V? It according to the formula of 1F equal to 1V plus 1 upon U, it will be 1 upon F minus 1 upon U. Now F is minus already 1 upon F, and when U will come here, it will become minus of 1 upon minus 25. So 1 upon 25 1 upon 25 minus 1 upon 15. It will be 5, 3, 5, 3, 15, 15 by 75. 75 upon 3 minus 5. It will be minus 2 by 75. And it is actually 1 by V. So because it is negative, we are seeing, it means that V will be formed here. Okay, something, I mean, this side of the mirror. So if on reversing it, it will be 75 by 2, which will also be negative. If I convert this in proper number, in non-decimal, then 236,127.5 minus 37.5. So we have V as 37.5, which is also negative. Now we have all V and U and F. Now I have to check whether what this formula is saying. Okay, so what Newtons are saying is, if you have a concave mirror, you make a line and place its center, which is E. Now center is also known as F, which is focal length of any mirror or lens. So F here, then I have to denote it like it is E. It was E, okay, in the book. Now I have to bisect it here and name it as, sorry, center is okay. Okay, okay, okay. Now what Newton is saying is, if you take a no, what Newton sir is saying is that if you take concave mirror and let pass a line from here and mark its names like this is pole. Now its center will be, let's suppose this C. Okay, and in this, mm, and in this we are not seeing such a poly. No, this is this APNCE, and in this figure we have taken E as the center, and here I have denoted it as C. Now I have to take one V. Now if I see above, V is lying uh, beyond the 30, which is, now in this mirror, let me firstly mark F. F, which is focal length and which is given as 15, minus 15, but I will write it, and I will write it minus 15. F. Now U is also given minus 25. U is minus 20. So center will be 30. Okay, because it's double of F. So minus 30, and U is lying at minus 25. It means between F and C, here something. It will be minus. It is minus 25. Now we have calculated the V also, which is minus 37.5. So minus 37.5 will lie something here. Minus 37.5. Now we have to check this ratio where it is T by TQ equal to T upon, okay, okay. So the ratio was, I am again writing it, T capital Q upon T E equal to T E upon T and small q. This was the ratio for this. Now, what this is saying is T. E is the center here. So what will be T? It will be focal length, right? T will be focal. So from the focal length to the point Q, which is our image distance. So let me find it first. Here, image is this 37.5, and the focal is 15. So if I calculate the distance from here to here, it will be 37.5 minus 15, which is 15 plus 7, which is 22, 22.5. So 22.5. So I write it as 22.5, and which is our FV, from F to V, upon. Now, what I have to take next is TE. And here, from the focal length to the E, which is our center, C, which is denoted above. So from the F to the center, which is 15, I will write it as 15, 15, now equal to, again the center here, 15, and below is from F to the small q, which is our U, i.e. the object's distance from F. We have U here, which is 25, so 15, 25, which is at 10. So is it following this ratio or not? We have to check. So 22.5 upon 15, if I remove the decimal and uh, put 10 in the denominator with 15, it will become uh, to 150. Now 25 is 15 square. It means it can be written as 15 upon 15, and below is 15 into 10. 15 and 15 get cuts, and it's again 15 by 10, which is equal to the RHS. So thus this ratio follows. So what I have done here is I am again writing TQ and TE. The TQ is the length from the focal length to the V. Okay, let me write this length. Uh, okay, so let me write this where L denotes L, where L denotes the length. So length of from F to V. So from F to V upon, from length of, from TE, which is center. So from focus to its center, it means I can write it as F only, because it's 2F minus F, right? So F is length equal to, again I'm writing L length of focal length here, repeating it as continual fractions, on from T to small q, which is from focal length to the U here. So from focal length to U. So this was the relation which is coined in this book, and it works also. So this was the relation which I found something different from 1 upon F equal 1 upon V minus 1 upon U. So if you have F, if you have U, if you have V, or, and yeah, I mean, if any two from them, then you can, using this relation also, you can find this. So thank you.